Hi guys, and thanks for joining me for this part 4 of basically layer 3 router concepts. So in this particular last video clip guys, I just wanted to walk through, because in the last part 3 we basically saw a message going from PC0 over to PC2, but I want to just ensure that you realize the full consequences of these packets going across the network and how the router works. So let's try this again guys. Let's go back into PC0 for a moment. I'm going to go back into simulation mode so we can walk through this again very slowly. So again, looking at this ARP table of PC basically 0, we can see it has mappings for 1.1 and 1.11. Who's 1.1? We can see the MAC address of the interface here, and we can see the MAC address of, for example, PC1, which is 1.11. Okay, if I wanted to check my own MAC address, I could do so using ipconfig/all. And again, I would need to look for my physical address or my layer 2 address or my burned in address. These are all meaning the same thing. This is the layer 2 information. So I can see this one ends in CE84. So what happens when I go to ping, for example? And you might say, before I even ping guys, what does the router know? Does it know about mappings from this layer 2 to layer 3? And you'd be right in assuming it does. How could we see that? Well, actually, if I go to, for example, my router, what I can do is I can clear this just for a second. Let's just move down here. I'm just going to show you this command out again. It's show IP ARP. And what that will do, guys, is it will show me the mappings it knows about. So this router knows about, have a look, it knows about its own, for example, so this interface here is its own interface on gigabit 00. So this ends in 6601, but it also knows about 1.10. Who's that? That's our friend here, PC0. And look, CE84, it has the mapping. Okay, basically we also can see it knows about a mapping of itself here. This is 50.1. This is the interface of gigabit 0/1. Also guys, it has a mapping of 50.10. Who's 50.10? That's our friend PC2. So again, our router has this mapping of it knows where to send packets when it comes in, so that it doesn't need to ARP again. So it keeps this cache. This is often called an ARP cache. So here's the thing guys, when I go to ping now, this is my friend. So let's go back here. Let's do another ping. So if I go ping 192.168.50.10, what happens again? My computer basically says, okay, I can see that we want to ping 192.168.50. It basically says, the first question is this on my local area network? And the answer to that is it will say, hold on a second, my IP address is, for example, 192.168.1.10, as we know it, /24. So it basically says, hold on a second, that means the first 3 octets are the network portion and the last portion is the network portion. So it basically says, is this on the same network as me? And the answer to that question is, no, it's not. This is on the 192.168.50 network. That's not on the same network. So what it does is, it's going to basically, first of all, it's going to basically say, hey, do I have the MAC address for my default gateway? Because that's going to be my destination of my MAC address. Okay, so in this case, the ARP, we know that it already has the MAC address of, for example, its default gateway. What is that? So if we scroll back up here, guys, for a moment, we know from earlier on, we could see that its destination MAC address was 6601. So if I dig into this for a moment, guys, have a look. If I go into the outbound, look at that, destination 6601. Where's the source coming from? CE84. Who's CE84? That's me, of course. How can I prove that? I did an ipconfig, look, ipconfig of CE84. Okay, that's me. So what's the source in the IP header? The source is going from 1.10 up to 50. So it's going to a destination of 50.10. So here's what I want to do, guys. I want to now talk about how does the router work. So what's going to happen now is that this packet is going to come into the router. It's going to basically get this packet, and the first thing it's going to do is it's going to say, oh, it's going to strip off the layer 2 information. So remember, the layer 2 information in the inbound, it's going to get this and it's going to say, oh, I see you're coming from CE84. going to my interface of 6601. That's the gigabit. That's for me. It's going to strip that off. It's going to tear that Ethernet header off. And it's going to go, okay, let's look at where you're going to, Mr. IP packet. And it's going to go, okay, you're going to 192.168.50.10. This is the key important part. It's then going to say, okay, I need to look up my routing table. How does it look up its routing table? Here's its routing table. Show IP route. And what it will say is, where are you going to, Mr. IP packet? And it will say, oh, I'm going to 192.168.50.10. Which entry does this match? It goes through and it looks through these entries on the routing table and it says, is it going to the 192.168.1 network? No, it's not. Is it going to 192.168.1.1? No, it's not. Is it going to 192.168.50.0? That looks good, but it also checks in, does it go to 192.168.50.1? Exactly. So what it does at the end of this process, it says, actually, this is the best route that matches. So it's going to basically say it matches this route, it falls into this category, so I need to send out that packet out my gigabit 0/1 interface. And in order to do that, before it sends it out on the wire, guys, what it has to do is, it has to create another layer 2 frame address. So what does it do? It basically says, okay, I'm now going to be coming from a source MAC address of this gigabit 01 interface going to a destination of this PC2 MAC address. So in the out, look at the addresses that were coming in, guys. These are going to see, we're going to see that these change. Okay, look, it was coming in from a source of PC0, going to a destination of gigabit 01, 00. Look what's going to happen now. It's going to switch out or swap these addresses. I shouldn't say swap, guys. It's going to tear these off, so these are going to disappear. And what we're going to replace them with is, we're going to replace them with a source MAC of gigabit 0/1 going to a destination of 1A40. Who's that? Well, again, if we go over to PC2, and if we look at PC2's MAC address, so again, if we go in here and do an IP config all, so let's do all. What we should see, guys, is we should see the burned in MAC address of that address. So again, we should see, here it is, guys, 1A40. Can you see that? So again, 1A40. Who's 6602? Remember, that's the source MAC address coming from gigabit 01. How can I prove that? Go back to the router and I could do a show IP interface. Well, actually, I don't even need to do that. I can go show interface gigabit 0/1 and I could look at and find its MAC address. So again, look at that. It's ending in 6602. This is the gigabit Ethernet address for this particular interface, which is in this case 0/1. So what are we showing here, guys? It's showing that every single hop from one network to the next network, we're basically changing the layer 2 information. And this is so important. Notice though, guys, it doesn't touch, in this particular case, the source IP and the destination IP address. So again, they stay the same. So again, it needs to be able to route back this information back to PC0. So what's going to happen? This packet is going to go now to PC2. It's going to go back all the way to PC2. What PC2 is going to do? It's going to send an ICMP response message. Who's it going to go back to? It's going to come in here. It's going to go inbound. It's coming to 192.168.50.10. What's it going to do now? It's going to swap these around. It's going to say now to go outbound, it's going to say it's coming from 50.10 going back to 1.10. Have a look, guys. See the way it swapped those around? Now what it's going to do is it's going to basically use the destination. So again, here's the source MAC address. Who's that? PC2. Going to a destination of 6602. So that's the destination MAC. Now if I go press forward again, what's going to happen is that's going to go to the router. What's the router going to do? It's going to look up. It's going to say, is this for me? It's going to rip off this particular Ethernet header. It's going to basically say, where are you going to, Mr. IP packet? Oh, you're going to the one network. It's going to need to look up its routing table. So again, what's it going to do? It's going to look up its IP routing table. It's going to say, where do you need to go? If you're going to the one network, it's going to basically say you need to go out gigabit 00 port. So it's going to send that IP packet out gigabit 00. Okay. Also, what you'll notice, guys, is if I click on this particular envelope, Notice again, it's going to, before it sends it out on the wire, it's got to change this information in the layer 2 frame. So again, watch what it does. Before it sends it out, it's going to change the MAC address of this interface to the MAC address going to this destination MAC address. Let's have a look at that. So notice again, it's changed. Again, 6601 is the MAC address of this interface going to CE84, which is the MAC address of PC0. And that is the end of the story, guys. That is a successful ICMP message or a ping test across the network to ensure that we've got connectivity from one network, network 1, to network 2. Okay, folks, I hope you've enjoyed parts 1 to 4. Please watch out for more videos in the future, and I'll see you soon. Thanks for viewing. Bye for now.